On this part of math, we are going to talk about parent functions and their transformation. So what are parent functions? And what do you know? What do we need to know about them? And what do we need to remember and to memorize about them? Okay, these ones are main parent functions. Here we have 8 parent functions. Okay, in parent functions, for example, we're going to take one of them here. This one here, which is absolute value function. Its function now is f of x equals absolute value of x, and you can write it as y equals absolute value of x. This one now is called absolute value function. Good. How is its graph? This is how its graph is. As you see, it is exactly like letter V. It is exactly like letter V that goes from 0 and 0 here. As you see, it goes into both directions, left and right. Okay, this one is called absolute value function, and this is its equation, y equals absolute value of x, and this is its graph, which is like letter V. It goes from 0 and 0 and symmetrical around y-axis, so it goes left and right. Good. This is now called a parent function. So this one now, absolute value, is called, this one here, called a parent function, and this is now its graph. Okay, what do we need now to remember? We need to remember that this function now is called absolute value function, and its equation is y equals absolute value of x, or f of x equals absolute value of x. And we need to remember its graph, how its graph goes. We need to memorize it in our minds. We need to memorize its graph. Good. Same thing for other ones. Same thing for other ones. We need to remember now to memorize the name of the function, its equation, and its graph. Plus, we can memorize now, if you now memorize these graphs in your mind, you're going to memorize domain and range of these ones. Okay, how domain and range? We can memorize them as well. For this example here, as you see, the domain are the values of x. So that means these ones now, the values of x, they participate in the graph. And these values of x also, they participate in the graph. So that means the domain is from negative infinity to positive infinity. This is the domain. And you memorize it. Absolute value now, its domain is negative infinity to positive infinity. Always. Always, whether is it a parent function or not a parent function, will be what its graph. And the domain, as you see, it goes here and up. That means from 0 to positive infinity. And the domain is the range. The range, it goes from 0 to positive infinity on y-axis, and the range is changed. When there is transformation, the range will be changed. Just memorize at least what's the domain, and for the range, we're going to understand it when we make the transformation, how it is changed. But for now, for this graph, as a parent function, it goes from 0 to positive infinity. Good. Here now, for cubic, the same thing. We need to memorize the equation, which is y equals x power 3. Y or f of x, they are the same. So y equals x power 3. And this is its graph. You see, you memorize it. It goes from 0 and 0 this way. This is called cubic function. And as you see, its domain is positive infinity, negative infinity, and its range is positive infinity and negative infinity. So that means this function now, which is cubic, domain and range, positive infinity to what? To negative infinity. And here's the same domain and range, positive infinity to negative infinity. So that means all real numbers, all real numbers. Good. So we understand here now cubic function. Now this is its function, and this is equation, and this is how is its graph. And quadratic also, it's important. Y equals x power 3, power 2. Y equals x power 2, which is here. Y equals x squared. This is also quadratic function as a name, and its function, its equation is y equals x squared, and this is how its graph. It's similar to letter U, upwards. And I hope that is clear. And it goes from 0 and 0. It goes from 0 and 0. It passes through the points 0 and 0. So we need to memorize its graph, its function, its name, mainly. And also we can add, and we remember its domain and range. Okay, same thing for linear. Y equals x. Y equals x. This is its graph. It goes from 0 and 0 as line. It's a straight line. What is its real domain and range or real numbers? Just memorize here now. It's equation, name, and also what? The graph. Here is square root function. Square root function goes from 0 and 0, then it goes this way exactly. It goes what? This way. And this is how it is. Y equals square root of x. This is its equation. And it is called the square root function. Square root function. Here, this one is called y equals 1 over x. This function is called the reciprocal function. And this reciprocal function, its graph, as you see, it goes this way. Because it cannot pass from 0 and 0. It cannot pass from 0 and 0 because when x is 0, it's undefined. When x is 0, that means 0 in the denominator, so it's undefined. Summarize it, it goes this way, and it goes from 1 to 1 and negative 1, negative 1, and it is there in the negative and in the positive what? 2 quadrants. Good. Here now, this is exponential, which is y equals any number, not just e, any number. It can be 3 power x. Okay, this is how its graph is gonna be. It goes from this way, then it goes to the 1, then it goes what? It goes up. Here, this is now the inverse, so it goes the same, but it comes here. This one, it goes from the negative x. This one, it goes from the negative y. Then it goes to the 1 and it moves what? This way. And this is called what? Log. That means logarithmic. Y equals what? Log x. Log or len are the same, but the difference is the base. For len, the base always 10. For log, the base can be any number. So we understand what these ones called parent functions, and these ones main parent functions. And we have other parent functions like sine, cosine, integers. But same thing, you understand for these ones, you apply it for other ones. Okay, again now, what do we need to remember? We need to remember parent functions, what they are called, their names, their graphs, their equations. If we understand these ones now, we can understand the transformation of these functions. And this is the second point. So first point, we understand the parent functions. Second point, we understand their transformation. How their transformation here, we're going to understand it at this point. If we go to the graph now together at this point, look, here this function is, as you see, y equals absolute value of x. And this is how its graph is, as you see. This is how its graph is, as we mentioned before. As we mentioned what here, as you see here, this is how we mentioned it. So we're going to understand now this one. As you see, y equals absolute value of x. This is now its function. And it is like letter V, it goes from here. Okay, we go to graph it now. When we go to graph this function, okay, when we graph it, this is how it is. As we see, we graph it here, y equals absolute value of x, and we see its graph, as you see, it goes this way and this way from 0 and 0, and it is like letter V. Okay, now, we will understand now what transformation can occur for this function. That means, how can I take this graph down, or I take it up? How can I move it left? How can I move it right? How can I make for it reflection on x-axis or on y-axis? I'm talking in general for all these parent functions. Okay, we're going to take this one as example. And what is applied for this function is applied for all other parent functions. So you need to understand this transformation now. We're going to make just for it, for one example, 2 examples, then it works for all other parent functions. Now we have taken the first parent function, which is what? Absolute value, and we wrote it this way. Good. Now, if I want this graph now to go down 2 steps, as it is, but I want to move it 2 steps down, what should I change in the equation? So if you want to move the graph down, just go to right here, go to right, and the equation, you see it top left. Top left, just say right -3. If I write -3, what will happen now? This graph of the parent function now will go down 3 steps. As you see here now, it goes 3 steps down. That means this one now is called translation, and it's type of what? Of transformation for parent functions. Okay, now this graph now, is it now called parent function? No, it's no longer now called parent function. So that means the parent function, after you transform it, after you translate it left to right or up or down, it will no longer called what? Parent function. Parent function is just the original shape, the original graph, the original function, the original equation. If you make transformation for it, it will no longer called what? Parent function. And in general, such equation in general is repeated in many exams, So you understand now, if we want to write minus a number, it will go down same number of units written in the equation. Okay, if we go back now to the original one, this is now the original parent function now. If we want to move it now 2 steps up, if we want to move it 2 steps up, just you write here now plus 2. If you write now plus 2 in the end, you see if the equation, you're going to see it will go up. It will go up 2 steps. As you see here, it goes up 2 steps. So that means now we understand. If we want to move it down, just we might write minus in the end, and the further right of the equation, we write what? Minus that number to move it down, or plus that number to move it what? Up. And I hope you understand it. And this one now, this transformation to go up or down is not just for this parent function, which is absolute value function. No, it works with all other functions. It works with all other functions. If you want to move them down or up, just you add a number plus or minus at the end. Okay, now we move now back to the original one, which is the parent function get. And here, this is how is it. Now we understand how to move it down and up. How we move it now left or right? How can you move it left or right? If you want to move it left to right, go inside the absolute value, inside it, inside the box of the absolute value, and play with the x. That means now if you are moving left to right, you are playing with the x-axis. If you are moving up and down, that means you are talking with the whole function. So that means you are playing with the y, with the f of x, with the function itself. Okay, now if we write inside the absolute value, minus 3, just think of it now. It will go left or right. Look, for x, it's the opposite. It's the opposite here. If you write inside for the x, if you are playing with the x, if you make minus x, that means you are subtracting from the x-axis by 3. That means, to memorize it, it will go to the right side. So if the x here, x minus 3, you subtract 3 from the x, that means it will go 3 steps to the right. Look here now how it becomes. This is how will be its graph. So that means in this case, as you see, it's not now, it's on 0 and 0, it moved to 3 and 0. That means it moved 3 steps to the right. So you understand now how we move it up and down and how we move it right. And what about how we move it left? If you want to move it now left, it's the same idea, but instead of writing plus 3 and minus 3 here, we write, instead of minus, we write it what? We write it plus. If it is plus, it will go where? It will go to the left side of the x-axis 3 steps. So we understand now how to move it left and how to move it right and how to move it up and how to move it down. Okay, just I'll add something here now, but we'll go back to the original function, which is our main parent function. This is the parent function, y equals absolute value of x. Good. Now I want you to move it. I want you now to think, how can I move this function 1 step right? 1 step right. Good. And I want to move it 2 steps up. 2 steps. We want to move it what? 2 steps up. 2 up. Okay, what should I change in this function? This is the main function, y equals absolute value of x, which is the parent function. Now, and its graph is its graph as v from 0 and 0. Okay, if I want to move it now 1 step to the right and 2 steps up at the same time, what should I change in the equation itself? Think of it before we solve it. You can pause the video and think of it. Try to understand how it will go, its graph, how it will go, and what should I change in the equation itself. Okay, first step here, if we go back now to the equation here, y equals absolute value of x, top left. If we want to move it 2 steps up, we know we write at the end further right plus 2. Good. As you see here now, it goes 2 steps up. Thank you. What we need more? We need 1 step to the right. 1 step to the right, that means you are playing with the x-axis. So we go to the inside of the absolute value with the x. Then we write what? If we want to move it right, we write minus for the x. So that means minus 1. As you see, this is how it goes. This is how it goes. As you see here, it was at this point, then it moves 1 step to the right, then it moves what? 2 steps up. So 2 up and 1 right, as it was here, 1 right and 2 up. That means its vertex now, its vertex, it was here 0 and 0. Now it becomes what? It becomes 1 and 2. 1 and 2, it becomes what? This is now its vertex. I hope it's clear now how to translate functions up, down, left, and right. And again, I repeat, this is not just for this function, it's for all the parent functions. For all the parent functions. That means if we add here, if we draw here another function, for example, we draw this function. I think you know this function now. What is this function we said? It is called what? If you go back to the point here we explained, we are talking about this function, right? What is this function now? Square root function. This is square root function. As you see, this is its graph here. Good. This is now its graph. And now this is what? Its equation. This is here, its equation, top left. Okay, this one now, same thing. If I want to move it 2 steps right or 2 steps down or left, okay, same thing. If I want to write now, if I want to move it 2 steps right, 2 steps, I'm going to start by 2 steps down, 2 steps down. I need to write here what? Minus 2. Look at the further right of the function. That means at the further right, I write minus 2. In this case, what will happen? It will go 2 steps what? Down. As you see, it goes 2 steps down. And if I want to move it 1 step right, I go inside the x, inside the square root here, inside it, and I write what? Minus. For the x, we write minus, but inside the root itself, minus 1. So in this case, as you see where it will go 1 step to the right. So that means, as you see, with these ideas that I'm talking about, for translation of the functions, it works with all the parent functions. Just memorize the parent function. What is its equation? What is its graph? Then when we make transformation for it, that means when we translate it left to right, you remember. Okay, what questions they can come to you here? I can give you now one question. I give you this one here. And I tell you now, how many steps it was moved to the right? So that means from here, you're going to understand what is left to right is what is related to the x, not here, or it is related to the y. So that means here, as you see, it is minus 1 for the x. That means it moved 1 step to the right. And negative 2, it means it moved what? Down. Or sometimes you are given this graph, and they ask you what is its equation. What is its equation? So look, if they give you the equation, you know how to choose which graph is it. If the graph is given, you know what is its equation by understanding what is the main parent function graph and its equation, and by understanding how the translation happens when you move it left, right, or up, or down. And I hope that is clear here now. We're going to move now back to the same function, which is our main function, which is what? Absolute value function. This is now absolute value function. Good. This absolute value function now, y equals absolute value of x, and s is its graph from 0 and 0 like letter what? V. And we understand now how to move it left, right, up, and down. Okay, now one question. How can I reflect it upside up down. How can I reflect it? Now, as you see, it is opened up. How can I make it open down? That means how can I reflect it on x-axis? On x-axis, when you reflect any, for example, as you see this one now is opened up. If you want to reflect it down on x-axis, that means it's gonna be like this. It's gonna be what? Like this. Okay, what should I change in the function now in order to be reflected down? What should I change? Just go there, and make negative for the whole function. When I say make negative for the whole function, that means y equals, after the equal directly here in this case, we write minus. As you see, when we write minus there, what will happen? It will be reflected down. As you see, it is reflected now on x-axis. And I hope that is clear. So that means when you write negative there, it means we are writing negative for the whole function. If we are writing negative for the whole function and the function is related to the y, so that means we are changing the sign of the y. So that y was positive, then it becomes here what? Negative. In this case, this is what I'm talking about on the previous point that I talked. Now here, domain, is it changed? Domain is still from negative infinity to positive infinity, and it is not changed for absolute value function. Whatever you transform it, left, right, up, down, whatever happens there, the domain will not be changed. It is all real numbers from negative infinity to positive infinity. But now the range is changed. On the previous graph, it was from 0 to positive infinity. But now, when it is reflected, the range now will become from 0 to negative infinity. That means negative infinity to what? To 0. And I hope that is what? That is clear. So we understand now how we reflect any function what? On the x-axis. That means upside down. Okay, now, just I ask you one question now. Try to solve. Okay, we move back to our parent function. This is now the parent function. Good. This parent function now, if I want, we understand how to reflect it upside down. How can now we reflect it left, right? Okay, look, what will happen now if I write here negative with the x inside the box? Inside here now, if I write negative inside the absolute value here, what will happen for the graph? Will it be changed? Look, it will not be changed. It will keep being as it is. Why? Because any negative inside the absolute value, it will be changed into positive. Any number inside the absolute value, as we know, any here, -3 inside the absolute value, it means 3. So that means the negative will not change. And this one now is even function. And even function are the functions that are symmetrical around the y-axis. That means even if the x signs are changed, y values remains there, so its graph will remain there. Good. But this one now is different from other functions. Okay, we're gonna move to the other function here to take examples on, which is what? A square root function. As you see, this is now square root function. Square root function now, if I wanna reflect it upside down, that means upside down means on x-axis. Just I go here now, I go here before, and I write here negative, as you see. When I write negative here, what will happen? It will be reflected upside down. Look how it's gonna be reflected. This is how it is reflected. You see, when I write negative there. So that means when I write negative there, I'm writing negative for the whole function. I'm writing negative for the whole function. That means I'm changing the y values, but x values remain as they are. So that means the reflection will be on x-axis, that means upside down. And I hope that is clear. Okay, now I move back to the original function, which is our parent function here, which is y equals the square root of x. This function now, if I want to reflect it left, right, look, now here it is, as you see, it is going to the right here. If I want to reflect it left, right, that means I want to move it this way. I want to reflect it to the left. What should I do? Or what should I change here on the function? So that means if you want to reflect it right, left, right, you change only the sign of x. So that means I go here to the sign of x that is inside, and I write negative, and look what will happen here. As you see, it is reflected left, right, when you write there what negative. So look, all these transformations happen for the parent function. If you don't memorize what is the graph of the parent function, what is its equation, you will not understand what type of transformation happened. You will not understand that this is reflection, and you will not understand what reflection is it on the x-axis or on y-axis, and is it transformed left to right or up or down. So memorize the parent functions and their graphs, and also their equations and their names as parent functions, and understand what steps in transformation. You need to understand then, after you memorize these parent functions, you need to understand how you move them, how you move their graphs up, how you move them down, how you move them left, how you move them right, how you make for them reflection on y-axis and on what? On x-axis. And I hope that is clear. And I hope that is clear. Just we'll add something here. If we move back to the original function that we are working on, which is what? Absolute value function. This one now is the absolute value function. As you see here now, as you see, its graph, it goes from which points? It goes from 1 and 1, 2 and 2, 3 and 3. You see, it goes from these points. And here it goes, same thing. Okay, just one question. What number is written here, but it's not? What number is there, but we don't write it? What number is there? The number there is 1, and the 1 here, it represents in general here the slope. What is the slope of this line? It's rise, which is one step over run. So rise over run, 1 over 1, that means it's 1. This one now is the number that is written here. Okay, now what will happen now? If we change the number that is written here, it is 1, but we didn't write it. It is 1 here. What will happen if we write 2? And instead of 1 here, we write here, we write 2. What will happen now? What do you think now will happen? Okay, now look how the graph will be changed. Look now, the graph goes from which point? It goes from 1 and 1, 2 and 2, 3 and 3, negative 1 and 1. It goes from these points. Look what will happen. What will happen? Its slope will increase. How? Look here what will happen. You see, this is now how it's gonna be when you write there 2. And this 2 here, it represents, just to help you to memorize it, it represents rise, which is 2 steps over run. 2 over 1 is 2, so that means this is how. So this one now, what do we call this process now? So we understand translation, left, right, up, down. We understand reflection on x-axis and y-axis. And now just the last point is how we understand the stretch. So that means now this function, now we call it, it is stretched up. It is stretched up. So that means this function now is stretched up. When we write a number, here, that is greater than 1. That is greater than what? Than 1. And I hope that is clear. Same thing if you write here, if you move back to its original, this is how is its original. Okay, what about if I make it 0.5? What about if I make it and I write here 0.5 outside? Look how its graph will be if you write 0.5. As you see, this is how it works. This is how it will be. So we understand 3 things now. We understand, after we understand parent functions, we understand its transformation as translation left, up, right. We understand its reflection upside down or left, right as reflection, and I understand how to stretch it up or to compress it vertically or horizontally by multiplying by a number outside. And I hope that is clear now. The questions then, sometimes they come to you. They give you a function, then they ask you what is the parent function. If they give you a function just like square root and there is translation in it, and they ask you what is the parent function, you need to write what is the original parent function of that graph. For example, if I have here a function, and I tell you now what is the parent function of this function, of this graph. What is the parent function? Will you say y equals absolute value of x? Then you say, okay, it was transformed It was translated 3 steps down, so minus 3. Is this one now the parent function? Okay, we said and memorize that if there is transformation happens for the original, which is the parent function, it will no longer called what? Parent function. So that means if they ask you what is the parent function of this one, you memorize the parent function, which is y equals what? Absolute value of x. This is the parent function. So again, as a final just idea, you need to memorize these parent functions. These parent functions are important. Okay, and we need to memorize, as you said, the name, the equation, and the graph. And you need to understand then the translation. Translation happens for all these ones. This one is as well. If you write it here now, you can move it left, you can move it right, you can move it up. Okay, you can take just as example here now. How can I move it? Okay, before we go to the graph, just tell me here this function now, y equals x squared. Okay, if I want to move it 2 steps up, okay, I write here plus 2. Good. If I move it 2 steps down, I write just here minus 2. Good. What about if I want to move it 2 steps right? This function now, how can I move it 2 steps right? In this case, look, you need to rewrite it to be y equals, then you write squared here. You write squared what? Here. Now, if you want to move it 2 steps right, that means you go to subtract from the x2. In this case, it will go what? As you see, it is a parenthesis, and the top is the power is 2 there. So parenthesis, you write, and minus 2, in this case, it will move 2 steps right. And if you make it plus, it will move what? 2 steps left. So this is now, as I said, it works for all these functions. Even for this one, as you see here, it is y equals any number like 3x. If I want to move it 2 steps right up, I write here plus 2. It can go up. Minus 2, it will go what? Down. And here, plus 2 on the x, that means in this case, it will go 2 steps to the left. So as you play with the x or with the y, with the whole function, just memorize something as well. Y equals absolute value of x. When we write here plus 2, it will go 2 steps where? 2 steps up, right? It will go 2 steps up. And this 2, as we know as math, we can move it here. So that means it's the same thing like y minus 3 equals minus 2 equals absolute value of x. So that means this plus 2 here, whether is it here or you move it to the other side, you need to understand how it works, how it works here at the end. And I hope that is clear for parent function, and you are able now to solve any question related. And in general, the tests, the exams in general, every year you have questions from parent function lessons, and they are very important. Thank you so much. See you in other videos.